Hello everyone, we are from class S1 to 4. Today, for our maths discussion, we will talk about matrices and system of linear equation. First, let's look the history of matrices and system of linear equation. If you can see here, these two are the mathematicians. The term matrix was introduced by the 19th century English mathematician James Sylvester, but it was his friend, the mathematician Otto Cayley, who developed the algebraic aspect of matrices in two papers in the 1850s. Now, let's talk about meaning of matrices. In mathematics, a matrix is a rectangular array or table of numbers, symbols, or expressions arranged in rows and columns. For example, the dimension of matrix here is 3 times 4 because there are 3 rows and 4 columns.
There are many types of matrices, which are row matrix, column matrix or vector matrix, zero matrix or null matrix, diagonal matrix, scalar matrix, unit matrix, upper triangular matrix, and the last one is lower triangular matrix. Matrices involve of adjoint of matrix and inverse of matrix. Adjoint of matrix is transpose of the cofactor matrix of that particular matrix, that also called the adjugate of matrix. Inverse of matrix is the inverse of a matrix A is that matrix which when multiplied by the matrix A give an identity matrix. The inverse of a matrix A is denoted by A inverse. Actually, I have a question to solve, but I don't really know how to solve it. Can you guys help me?
Don't worry, Ain. I'll help you to solve question B. So let's start. The table below show the quantities in kg and the amount paid for the purchase of 3 types of fruit by 3 customers in the supermarket. The first customer is Rashida. She's buying 6 guava, 3 star fruit and 9 dragon fruit. She has to pay 94 ringgit 50 cents. While Umina buy 3 guava, 6 star fruit and 9 dragon fruit for 99 ringgit. Another customer is Mary. She buys 6 guava, 6 star fruit and 3 dragon fruit and pays 79 ringgit 50 cents. Prices of 1 kg of guava is represented as RMX, while star fruit is RMY and dragon fruit is RMZ. The question asks to form a linear equation and a metric equation which is AX equal to B. A is the number of fruits, X is unknown and B is the total number. First, let's take the detail before we solve the equation. Look, this is my answer for linear equation. It's really easy, right? This is my answer for metric equation. AX equal to B. So guys, I hope my explanation will help you understand better for this question.
Another part of question which is not discussed in this video that to find the value of P inverse. For the next question, rewrite the metric equation AX equals to B in the form of KPX equals to B, where K is constant and P is the metric defined as P inverse. Determine the value of K and find the value of X, Y, and Z. How do we solve this? First, we must simplify the previous answer. Therefore, we factor out 3 to make the number become smaller. Therefore, we will get the answer which is value of K equals to 3. Next, we move the K value which is 3 to the right hand side. So, it will become 1 over 3. After that, we multiply it with 94.50, 99.00 and 79.50. So, we will get the answer. To find the value of x, y, and z, we must move the p to the right hand side. Therefore, p will become p inverse. So, just substitute the value p inverse that have been shown in the previous slide and multiply it with the answer that we already calculated earlier, which is 31.50, 33.00 and 26.50 to get the final answer. Therefore, the final answer for this question is x equals to 4.50, y equals to 6.00, and z equals to 5.50.
There are many of application of matrices in daily life. Like example for dance, it's to organize complicated group dance. Second is for games, especially 3D games. Use it to alter the object in 3D space. They use the 3D matrix to 2D matrix to convert it into the different objects per requirement. And the last one is also for geology. Matrices are used for taking seismic surveys.
1, 3, -5 and 8. This is just a row of 4 numbers and this can be represented in different ways. We can write it as an array of numbers horizontally like this, or we can write it as an array of numbers vertically like this. The first part, as you can see, has 1 row and 4 columns, and the second part has 4 rows and 1 column. There's another way in which we can write the 4 numbers. The first 2 numbers in the first row and the last 2 numbers in the second row. All these 3 things you see here are called matrices. Each of these is a matrix, just an arrangement of rows and columns. But how do we properly define it? We can say that a matrix is a rectangular arrangement. But a rectangular arrangement of what? It can be anything. Numbers, letters, other characters, anything. A matrix is made up of rows and columns. The first matrix has 1 row and 4 columns. The second one has 4 rows and 1 column. And what about the third one? It has 2 rows and 2 columns. So a matrix is just a rectangular arrangement of rows and columns. But there is one important condition we need to keep in mind. Each row needs to have equal number of elements. For instance, in the second matrix, each row has 1 element, and in the third matrix, each row has 2 elements. And each column also needs to have equal number of elements. In the first matrix, each column has 1 element. The second matrix has just 1 column, so it doesn't matter. And in the third one, each column has 2 elements. So a matrix is a rectangular arrangement of rows and columns in which each row has equal number of elements and each column as well has equal number of elements. So is this a matrix? Elements A and B in the first row and elements C and D in the second. It is a rectangular arrangement. Each row has 2 elements and each column has 2 elements. It is a matrix. And these 3 are also matrices. Okay, what about this one with 3 elements? Is it a matrix? The first row has 2 elements, but the second one just has 1 element. So it is not a matrix. What about this one with 5 elements? The number of elements in each of the columns is not the same. It's 2, 1 and 2, and this as well is not a matrix. So this is the definition. A rectangular arrangement of rows and columns in which each row should have equal number of elements and each column as well should have equal number of elements.